All right, this is standard 54, 55, and 56 all in one video grouped together. Okay, so starting with standard 54, quotient of powers. To divide the two powers with the same base, we're going to subtract the exponents. So the key word here is subtract. I'm going to first show you why we subtract, and then I want you to understand that you can just subtract every time instead of having to do the long way. So looking at example 1 here, um, I would expand it all out. So g cubed really means g times g times g. And h to the fifth really means h times h times h times h times h, 5 times. Okay, and then g, I'm going to bring down here. Just have one g at the bottom, and then I have h squared, which is h times h. So anytime you have a g in the top and a g in the bottom, they can cancel each other out. So I can cross this G and this G, and there's 2 left at the top. And then I can cancel that H with that H and that H with that H. And we can't cancel these out because there's none at the bottom to cancel them out with. So I have G times G left, which is the same thing as G squared left at the top. And then I have H times H times H also at the top, which becomes, okay, all right, this is standard 54, 55, and 56 all in one video. Okay, so 54 is quotient of powers, and it says to divide the two powers with the same base, we're going to subtract the exponents. So the key word here is subtract, but first I'm going to show you why we subtract, and then I want you to remember that we will always subtract. So with example 1 here, I'm going to expand it out. So I'm going to draw my line. I have g cubed, which is really g times g times g, and I have h to the fifth, so I have h times h times h times h times h, and then at the bottom I have 1g, and then I have h squared, so I have h times h. So anytime a variable is at the top and the bottom, it cancels each other out. So for instance, this g will cancel with this g, and these two are left at the top and there's nothing to cancel at the bottom with it. So for the h's, these two cancel out, these two cancel out, and then these three are still left at the top. There's nothing to cancel out at the bottom with. So this g, so we really have g, g, h, 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 and then nothing at the bottom. When there's nothing at the bottom, technically there's a 1, but we don't really have to write this. So we're going to rewrite it in exponent form. So g times g is really g squared, and h times h times h is really h cubed. And again, when there's a 1 at the bottom, you don't need to write it, so you can leave it just like this. And there's your simplified answer. Okay, so if you notice here, if we look back at the problem, this is g cubed and this is just g, which is really a g to the 1, and so all we did is subtract. Subtract the exponent, so 3 minus 1 is 2, and 5, and so we had 2 g's left, and then 5 minus 2 is 3, and we have 3 h's left, so h times h times h. So this is the expanded form, but really the rule is just to subtract the exponents. Okay, so example 2 here. Right away, whenever you see a number over a number, they cancel out. If it was two different numbers and we can reduce, we would reduce, but a number over a number, it just cancels out. So I'm just going to cross that out and worry about the rest of it. So again, I'm going to expand it so we know what's going on. So we have x squared, which is x times x, and then we have y times y times y times y times y. And then we have 1x at the bottom, and then we have y times y at the bottom because of y squared. So we're going to cancel out, we can cancel out, so that x cancels with that x, and then I can cancel those two y's and those two y's. So what I have left at the top is 1x, and then I have y times y times y, and I have nothing at the bottom, so I'm going to put a 1 for right now, and then I'm going to simplify it in exponent form. So we have x, and then we have y times y, which is y cubed. And again, I don't have to write the 1 when it's at the bottom. So there's your answer. Okay, so this is a problem why it might be important, instead of having to write all of this out, to just understand the rule. So who wants to write out 10 m's? Not me. So if you understand the rule, you don't have to do that. So you have k to the 7th and k to the 5th. You just subtract, and that becomes k squared, because 7 minus 5 is 2. Then I have m to the 10th and m to the 3rd at the bottom. So you subtract, and you get m to the 7th at the top. And then you have a p at the top and a p at the bottom. So that's really p to the 1 and p to the 1. Well, p to the 1 minus 1 is 0. So you no longer have any p's left. And so there's nothing left at the bottom. So you could put a 1, or you do not have to put the 1 there. And there's your answer. Okay, so 55 is power of a quotient. So all this rule is saying is that you take the power to the numerator and the denominator. So for instance, example 1, I have r over t to the 5th power. That means that you really have r to the 5th over t to the 5th. So the 5th power goes to both the numerator and the denominator. Okay, so example 2. 3p cubed over 7 squared. So the whole thing is squared. So the exponent's going to everything. So we really have 3 squared, and then we have p cubed squared. So if you remember that rule, you multiply. So that's p to the 6 over 7 squared. So we have, and then simplifying further, we have 3 cubed, which is 9, p to the 6 over 7 squared, which is 49. And that is the simplified answer. All right, and the last rule is the zero exponent rule. So this is a simple one. You'll love this one. Any number raised to the 0 power equals 1. So this is 15 to the 0 power, and so that just means that that answer is 1. And this whole thing is being raised to the 0 power. You have all of this. You could simplify all of that, but it's all being raised to the 0 power, so the answer is 1. Now this one, only the y is being raised to the 0 power. So the x to the 5th and the x to the cube, you still follow your other quotient rule. So you really subtract these exponents. So you have x to the 5th minus x to the cubed, which is x squared left, and then the y to the 0 power just goes away. It's a 1. You could put times 1, but we typically don't write the 1s in algebra, so we're just going to leave it as x squared. There's nothing left at the bottom except a 1, so you do not have to write it, and there's your answer. If you were to expand that problem out, just to show you, you really have x times x times x times x times x at the top, and then again you have y to the 0 power, so that becomes a 1, and then you have x times x times x at the bottom, and so that cancels out, cancels out, cancels out, and so you have x squared left at the top. Again, you get the same answer whether you expand or just subtract. Either way, as long as you remember that anything to the 0 power becomes a 1. In other words, a lot of times we don't even have to write it anymore. All right, here's your 2 you-try problems. Bring these to class, at least attempt them, try to get the right answer, and check your answers with your teacher in the morning.